Hey everyone, how are we doing? My stream up. I keep streaming in the background. Whoa, it's got like low def. Why is it low def? There's high def. There's high def. If you are here, say hey in the chat. It's been quiet today. What's going on? It's like we got a break coming up here. So much break. And the screen is showing. No, you can see the very edge. We're going to break the fourth wall right here. You ready? No, fourth wall broken. No. There we go. I feel like I'm off center. There we go. Fourth wall is no longer broken. You did not see the computer screen right there. It's not like there's a computer screen right over here. Not reaching off the screen. One of these days would be so cool if I had the whole area. We'll see if anyone shows up and has questions. Go into the live chat. Mewbot's here in the chat. I'm going to look at some. Let's go look at some packages right here. Let's check it out. So the feather package. I really want to examine this. Connor was mentioning the feather package. So Connor, this goes out to you right here. Library. Feather. So I think Connor's saying this is a. We should go read about it. Here's its function. It promises me the functions are there. Write feather looks to be how we'll write something. Read feather is how it's going to read. So we're going to take a look at this. Let's go grab. Gonna go grab the information on how to use this because I don't know how to use it. That would be important for us to know how to do. Feather package in R. Pretty new. It looks like 2019. Feather, a fast on-disk format for data frames. So there's a blog on it over here. Let's go check out the blog information on this. Here you go. Powered by Apache Arrow. Hadley Wickham. Awesome job, Hadley. Hadley Wickham's chief data science engineer, something, might have said it wrong, at our studio. Top stuff right here. We, Hadley and Wes. Who's Wes? I don't know Wes ML. Not that I know Hadley. Discuss some of the system challenges facing the Python and R open source communities. In particular, we wanted to see if there was some opportunities to collaborate on tools for improving interoperability between Python and R and external compute and storage systems. One thing that struck us, that's why R data frames and Python pandas, which is how Python does a lot of stuff, data frames utilize very different internal memory representations. They share a very similar semantic model. In both R and pandas, data frames are lists of named equal length columns, which can be numeric, Boolean, true falses, and date time, such as like lubridate, categorical factors, or strings. Every column can have missing values. Yep, can have NAs. Around this time, the open source community had just started the new Apache Arrow project. I don't know about that. I probably should. Designed to improve data interpretability for systems dealing with columnar or tabular data. In discussion, Apache Arrow in the context. Hey, Kayla, here for the review, but it looks like I'm the only one. Yeah, Kayla, put a question and we're going to look at this feather stuff real quick. Do you want to do a review question, Kayla? Feather is a fast. So you think about like as light as a feather. A fast, lightweight, and easy-to-use binary file format for storage data frames. It has a minimum API, pushing data frames in and out of memory as simple as possible. Language agnostic. Feather's files are the same whether written by Python or R code. Other language can read and write Feather files too. So this is a good way to transfer between. Okay, so we could just send it. Someone could make a data frame inside of R and send it over to Python for pandas. Good stuff. Good package. High read and write performance when possible. Feather operates should be bound by local disk performance. Makes sense. The Feather API is designed to make reading and writing data frames as easy as possible in R. The code might look like this. Library Feather. They always do the path that way. People always do the path. Write Feather. Oh, wait. And then you read it? That's just such a weird way. I don't like that way of doing it. Analogously, in Python, we have the path being saved into this. I always hate the way Python looks. Because they're calling it like the package right there, right? The feather dot. If you want, we'll do an example. We'll do a problem question here, and we'll do a question about, oh, you want Kayla, how fast is feather? Feather is extremely fast. I trust them on that. How are we? Oh, they're talking about the name of the data frame. Then they're overwriting the data frame? The more practice, the better. But I just figured, yeah. So they're saying, I'm going to take this. I'm going to try this real quick. I want to take a look at this. Connor suggested I try this out. So that's the pathway we're writing to. So let's go ahead and we're just going to try this out. We don't have any data, so let's go here and go to data. Like we've loaded up survey 10. And so that's the path we're storing to. Let's just call it mod data. I don't know what file format it stores as. That's the path. And then the name of the data frame is this. There's the name of the data frame. Okay, it worked. And so then we're reading it in here. Yeah, write it in. Well, it did really quick. It's right about that. And the pathway right here was my data. So let me go see what it stored this as. Where's mod data at? My data. Yeah, there's a file for it. Open file location. Yeah. What's the file extension on it? This is my data. Well, it creates its own file extension. And what's the extension on it? It's a feather extension, whatever that is. Yeah, this is pretty cool. I'll tell Connor suggested I look into this. So yeah, it created the file my data. I don't see an extension on it. It just can it not have an extension like a .csv or something? But that's the name of the file now is my data. And then you can load it in and it's a data frame and it's stored and you could then send this to someone in Python and it should carry the information and be able to bring over to Python. So that's pretty interesting. I don't usually use the path like that though. So they're doing a little bit slightly different. I wouldn't store my path. I would call this my data. I'd load that there and it would do the same thing. So I don't usually do this step that way. Just, I don't know. They like to do their arguments like that. I don't know why. Maybe I should. Maybe I should start doing that. Hadley Wickham wrote all this, so I should. But that's got it. Kayla, do you want me to do a surprise question or what would you like, Kayla? Would you like a surprise question or would you say like, do a 2 sample T, do a 1 sample T, do a 1 proportion, do a chi-squared, do some type 1, type 2 error? What do you think, Kayla? What should we do? I think I've learned a little bit about Feather right now. It's kind of just talking about Feather right now and in Hadley, in R on Hadley's laptop, which is very similar. So they're showing how to do it right here, creating a data frame, saving the data frame, all this good stuff. Love surprises. Well, let's do this. Let's head over here. Okay, it's time for surprises. Time for a practice question. Sometimes. Well, then do you? Let's go over here and write our own practice problem for 201 practice problem. Let's go check it out. Here we go. So 201 practice problem right here. We have here... I don't want to do that. I don't want to tell you what chapter it is. Let's see if students learn better in Stat 201 by using R or jump. Brian randomly selects 100 students out of his 200 next semester to use R to learn statistics. The 100 students who use R had an average score of 84 with a... Do you already know where this is going, Kayla? Can you tell me what we're doing right here? Because there should be enough information to kind of figure out which way this question is going next semester. Yeah. And a standard of 12. The other 100 students... Jump had a mean score of 100 or A2 and a standard deviation of 9. Cool. Is there evidence of a difference between the two? It kind of gives it away. Did you see where that was going, Kayla, with this? That we're testing difference between two means. Does that make sense? So right here we have a mean for one group, a mean for another. And what would we assume? What would we assume about these two groups right here? Whether a student uses jump or whether a student uses R to learn statistics. What would kind of be the base assumption? You can ask the Rock about whether a student uses jump or uses R to learn statistics. The key assumption would be what? Kind of the null hypothesis. The null hypothesis here being it doesn't matter because it's like my new favorite thing this semester. What we're doing right here is the null hypothesis would be that the null states that the mean for students using reverse alphabetical when we do this R minus the mean for students using jump is equal to 0. That's what the null would state. And the alternative would state that the mean for students using R and the mean for students using JUMP is not equal to 0. Because we're asking, is there evidence of a difference between the two means? And exactly, it doesn't matter. And so this is going to ask, is there evidence of a difference? Did you see that this was going to a two-sample t-test? Did it start to make sense as I was writing it, that we're going to compare the scores? Yes. Okay, TDF. Yeah, it's exclamation mark TDF. Oh, Kayla's already solving this away right here. I'll put the two apps in the chat. There's the app for the degrees of freedom to tell you which T you are using. And then Kayla might be going in and solving the T statistic as we speak to get the T to tell us how far the standardized difference is away between these. Kayla, amazing work this semester with all this right here. If you're saying, where's the app for the degrees of freedom? Because you know the two-sample T has the complicated degrees of freedom thing that we do. So we have to go over here and put in the sample sizes and put in the standard deviations. I think those were, they were 12 and 9 respectively. And so we're going to get something like 196 degrees of freedom. Oh, 183. I was pretty far off. We'll round this to 184 because when we go to the T applet, we'll eventually use this. It has to, this applet you generally have to round up, but it's going to be very similar to a Z at this point. Oh, no, you're fine. You're on the right track. You're doing the right questions and you're doing great. This is where we need to go. You were like, where's that T degrees of freedom applet calculator? Because the one sample T, if we were just comparing the scores of Stat 2-1 students, then what would be the degrees of freedom formula, Kayla? As a review, if we were just comparing scores of Stat 2-1 students, like do Stat 2-1 students score a 90 on the test? Like just one group. What would be the degrees of freedom for the one group and you just test the mean of that one group? Like if you say like we have 2-1 students and we want to look at their average score. Not comparing between another group, just saying we have one group, we test 150 students. There you go. It'd be 149 n minus. Exactly. I didn't say 150 at the last moment, so you're exactly right. I was asking for the formula. Great job, Kayla. Kayla, you're being here. I know you're at the max level, but I don't care. If someone else is watching, follow along. They're also getting these points. There you go. Great work, Kayla, and I really mean it. You get it. You know it. You saw the two-sample T, and you're like, this is the complicated formula that we solve with an applet, which is sometimes how we ask it on the test. So that told us which T we are using. Now we need to solve for that T statistic. So we're going to go y bar 1 minus y bar 2. That's the difference over s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. This is the standardization of the difference. And you need the one. And it's posted now. It's posted. It should be posted under review 3. Oh, I should have mentioned that. Terry posted it yesterday, didn't he? Also, I need to send out an announcement. It is posted, and I posted the videos too. So you're the first to see this. Under review 3, it should go to it. Mubot, you send us to the right spot here. The formula sheet is posted, so you can take a look at the formula sheet here with all the beautiful formulas. Seeing the standard error, I just wrote s sub 1 squared over n sub 1, s sub 2 squared over n sub 2. And that is for this portion right here for the test right there. And you can see everything we have. So there's the formula sheet. And you can also see the videos posted right here with the speed runs and all this good stuff is ready to go. Concept review videos, speed runs, and review tests. I got those posted yesterday evening. I put those online. So Terry, thank you to Terry for getting this up and going. And so you got the practice tests, all this good stuff right here, all good to go. So a lot of great material, just ready to go right there. So we have the formula on the formula sheet. So check it out, know how to solve it. And we're just going to plug numbers in. This solves out to our T with the degrees of freedom that we just found, just telling us which T we are using. We're going to go right here, and we saw a difference between the two scores of 4 points. 2 points. That's 2, if I know mathematics. And then the 12 squared over square root of 100. Oh, no, it's not square root of 100. What am I doing? Doing S over square root of N. Plus 9 squared over 100. That's 144 plus 81, 19 minus, it's 225, right? Over 100. We can almost do this one in our head. So 144 plus 81, 225, good. Divided by 100. There, square root that. That's, wow, it's 1.5? Cool. Have you found the T statistic, Kayla? I got the T statistic. And I can about tell you the p-value. Got a good guess at the p-value. Solve the equation right now. Give it a second. See if you can solve for the T statistic. See if you get what I get. Here's a hint. That hint was, see if you get the same thing. I mean, I basically just showed it. What is the T statistic? Positive or negative really wouldn't matter on the T here if you were wondering. Yep, 1.33. Great job, Kelly. You got this. You got this. 1.33. The biggest thing is knowing the notation. Make sure you know your notation. These are the standard deviations. Well, these are the means. I highlighted a mean as I'm talking about standard deviations. And the standard deviations are right here. And the sample sizes for each group were here. So making sure to know your notation. So now, what are we going to do with this T? And here's the thing, Kayla. We can guess the p-value. What are we going to do with that T? So the T is going to be right here at about 1.33333333. But since this is the two-sided does not equals, what do I need to do with this? I hate that it does that. It like brings it back up to where the curse is at. Took me a while to figure out why it does that. So now I reflected it. Does that make sense? I reflected it on the other side because this is where we landed, and the other side is one just as extreme, so we're going to double it. It should look symmetric, but my drawing skills are lacking today. And so here's the thing. This p-value right here, I have a guess of. Well, yeah, sure, we'll do it like this. It's the whole thing shaded is the p-value, like both sides shaded, because we're just doubling it. It's double, I promise. But the p-value is going to be very close to 17%. 17.4%. 17.4%, I say. Oops, wrong number. 18.5%. Should have guessed 18. The reason I know this is because I know the p-value here is about 20%. Great job, Kayla, right there. Yeah. Oh, no, good guess. Yeah. Because if it had been 1, you'd guess about 32%, right? If it had been 2, you'd guess about 5%. So it's got to be, so knowing these numbers on the normal curve, you'd say your guess, it has to be between 32 and 5%. Does that make sense? Like any number you guess has to be between 32 and 5% because we're further out than 1, but we're not as far out as 2. So it has to be between 32, which is the outside of 68, and the outside of 95 is 5. But remember, this does more exact decimal calculations. Like you're like, well, why is it 4.7? Don't worry, good question to ask that. But this is calculated exactly now on the T-curve with 184 degrees of freedom. So the exact p-value is this right here. And how does that p-value look? That p-value right there looks kind of what? Like that p-value right there is pretty this. 4-letter word for this. It's high. Exactly, Kayla. Great job right there. It's high. So I don't understand statistics. I don't know what's going on. I can see, like, someone might say, well, Brian's students using R scored 4 points better on 2 points, excuse me. Brian's students who used R scored 2 points better across the class. What would you say to me about that, though? What would you just talk to me like you're the statistics person? You'd say, what about this? I'd say Brian's students who used R scored 2 points better in the class. You'd say, but you know, I don't want to say the full thing because I think you can get it. This is where we do with statistics. We'd say, but that difference, according to the p-value down here, from when we ran the test on this, we got a p-value for this of, I think 1.85 right here. That's the p-value telling us that what we saw here, this difference of 2 points, this difference of 2 points that we observed between the groups, because the R students did do better. But the differences are rather this. Say 2. I'd love 2 points on my grade. 2 points would be great. I'll take 2 points all day long. But it might just be what? Because the p-value is high, it tells us this, that difference right there might just be due to what? I'll say, wait, no, the difference is small, and it's likely due to this. That's what the p-value tells us. The difference is likely just due to this. It's a small difference in terms of standardized metric, because the t is 1.33. So the difference is small and thus likely due to what? It's probably so like we're trying not to talk statistics for a moment. It seems possible that what to you right now? It seems possible that what to you right now? It seems possible right now that what for the difference? It seems possible to you. I can go a little bit higher. It seems possible to you or believable at this moment that what? It seems possible right now what? The difference what? Like it's believable. Like it's within the realm of possibility that there might be what difference? And that's what you're saying with the high p-value. Like, sure, that's possible. That the difference could be zero. It's like, well, maybe there really is no difference. Like the true difference. We observe a difference of 2 in the sample. This is the sample difference, but we want to know like for all students. So it's possible that there really is no difference. Like if more students were to do this, like, yeah, some students will score better, some students will score worse. And this difference of 2 might just be random variation for students' scores. Like maybe a really good student was taking the R, like used R. Maybe a student who had a little more trouble was using jump. It might not be the jump versus R. It might just be random variation of the groups. Like this is only a 2-point difference. And you know what's really interesting? If we go back to when we were solving the formula, watch this. Do you remember, and I'll tell you the answer to this, do you remember mathematically what the standard error was? The standard error of the equation, this bottom portion right here, solved out to what? I'll see if you remember. Do you remember what it was? It was like 1 point something. Because we divided 2 by it and got 1.3333. So do you remember what that standard error was? That standard error right there was what? We can actually do this pretty quickly because 1.5. So let's write out the confidence interval formula, which is the difference between the two means. So, whoops, I did a plus. Really? I want to be down here. The difference between the two means, we just look at the difference as our estimate, plus or minus the T star, let's make it 95%, with the degrees of freedom taken from it, and then the standard error of the differences. So rather than write this whole formula, what do you think I'm going to plug right here, Kayla? What do you think I'm just, because I've already solved it. So rather than write the standard error of the differences, which is s sub 1 squared over n sub 1 plus s sub 2 over s sub 2 squared over n sub 2 square root, rather than write all of that right there, what do you think I'm just going to plug in for the standard error? It's that you see, you're saying just take that 1.5. You already solved for the standard error. It's the same thing right here. But this is where, and I did want to point this out by doing this. Ooh, I can't write today at all. I mean, never can write, but you know, today's worse. These two things right here are not the same. This t right here and this t right here are not the same. They are not the same t. Because the t for the confidence interval has a what on it, which means a certain thing for it. The t for the confidence interval has this thing right here, which is very important for the t for the confidence interval. I'm like, yeah, very important. Because that star right there means you pick it based on the level of confidence, which means you choose it, exactly, which means you choose it based on the level of confidence. So we already know our degrees of freedom from the first time calculating this are 184, but now we want to build a 95% confidence, which means our t is going to be very close to 95% confident. The t is virtually 2. Does that make sense, Kayla? Like to build a 95% confidence interval, usually the t is about 2. Just depends on the degrees of freedom because 68, 95, you're kind of giving 95%. You've been doing a lot of great work on this, Kayla, and this is a good example. So that star right there means you pick it. You don't solve for it. You don't solve for it. The test, you solve for it. The t for the interval is the one based on the level of confidence, and it's basically 2 because we're using a 95%. So for all intents and purposes, and I'm going to cheat right here, I'm going to round this to 2. Kayla, can you try to do this? Solve now for this, because the margin, we'll do this really quick. Solve the margin of error for me. Just solve the margin of error, like plus or minus this amount. When you solve the margin of error, you're just saying plus or minus this. So you're just saying plus or minus this amount. Like whatever the difference is, plus or minus this. The margin of error is going to be what? So the margin of error on this interval is going to be what? Like the plus or minus this on the interval. Like whatever we estimate, plus or minus this amount. Could be off by about this amount. 3. That's it. There's the margin of error, just that last portion, everything after the plus or minus. And then what was the difference we observed? The difference we observed between the two means, so it's up there in the pink up there. The difference between the two means is what mathematically? What was the difference between the two means? The difference between the two means was what, which is what's going to be our estimate of the true difference. Our estimate of the true difference is going to be what? What is our estimate from the sample? From the sample, we get an estimate of what the true difference might be. It's like, well, I saw this in the sample, so that's a pretty good guess of what the difference is. My good guess of like, well, my one group scored this, 2. You got it. Yep, and that's found up here in this portion. That's the difference between the means. It's the same formula if you notice here, here, and here. It's the same thing. It's going to do it. It's going to do it. So what do you notice about this interval, Kayla, which tells us there might not be a difference? And I'll kind of show the full thing. What do you notice about the creation of this interval down here? If you solve it out, and the null hypothesis. Hence why we don't reject the null. What do you notice about the creation of the interval, which comes to the same conclusion as the null hypothesis? If you like look at 2 plus or minus 3, and you see, so you got it, and so that's the interval. And then what do you notice about the interval, which kind of says, well, maybe the null could be true. We're not saying the null is. We're just saying, like, I can't reject it. 0's in the interval. Exactly. It's a possible true value. God, yes. This is what I want people to see, where it's like, hopefully, like you said, it's all coming together. Yeah, like it's like, well, you can't reject it. It's in the interval. So the p-value for the test was high because 0 is a possible value of truth. It's like, well, maybe 0 is true. It's in the interval. So, yeah. And we just did the 2-sample t-test, the 2-sample t-interval. Let's check our conditions on it. We didn't do it. You ready here? Condition 1, Kayla, put it in the chat. This is just check of conditions. Condition 1, you know what it is. It's easy one. I'll do condition 2. Condition 1. Okay. You did? Oh, we did. Condition 1 is random. So we randomly selected these students. Condition 2 is 10%. These students are less than 10% of all Brian students. Do you know condition 3 and condition 4 for the 2-sample T? I swear I have a graphic for this. I might take a moment, Kayla, here. I'm going to be over and looking through the Discord here for a second. I'm going to try to find this. Did we delete it? I'm trying to find the conditions right here. All the memes. Did we like... There was a picture... People posted the craziest, like, Papa Shark stuff. So while Kayla's figuring out those answers, I'm going to try to find this. I'm going to post it again. Well, I'll be. I cannot find it. I'm so bummed. I'm trying to find this one picture. And I cannot find it. I think we might have deleted the channel with it on it. We had archived channels and we deleted them. And I'm like, I might have to go get the graphic from like a video. And, because I think we might have archived the channel. Seeing the power outage and everything. Yeah. Yeah, no, you got it. Large enough N. No, Kayla, you're right. Large enough N because we need to, well, but we call it the nearly normal. So you're sorry, Kayla. I was looking for the graphic, which I'm having the hardest time finding. We might go try to find it real quick, Kayla. You want to go on a search with me for the graphic? Let's go find that graphic. And then the last condition is independent means. So we're going to go on a YouTube search right here through Brian's old videos. Let's go on a YouTube search right here. Find the graphic and post it in the Discord for people to see. Because this is a very helpful graphic. So we're going to go back in time. So office hours, there we go. You just watch the hair get longer. Oh, man. Craziness. BAS 474 review. Game show review for test 3. I had like just gotten a haircut, I think, then. So they should see the conditions at some point on here. We'll do a review. I have to show the conditions on here at some point. No? I'll just never show the conditions I wrote. Spent so much time making that cool graphic. I could, as long as I've been searching for this graphic, I could just have gone and remade the graphic. Where you at, Brian? Short hair, Brian. Medium hair, Brian. Oh, it's a graphic I created to show. I don't know what's up with my lighting right there. I'm good at finding stuff. It's a graphic I created to oh, people telling my Smash Bros effect. It's a graphic I created to go over the conditions, and I created it last semester or so. I used it over the summer, I thought. So it might be best to look at last semester. Final review. Here's long hair Brian. There's Brian with long hair right there. Where's our... We do conditions first. Oh, wait. There it is. I'm drawing on it, though. I'm drawing on it. No. Oh, my gosh. Wait. We found it, Kayla. 2 seconds. This is it. There we go. Let's do it. There it is, Kayla. There's the way to remember this. I'm going to put this in Stat Tool 1. Trying to memorize. Let me do this right out. Stat 201. Trying to memorize those pesky conditions for tests and intervals. Here is the step-by-step way to get them right each time. Don't forget those. I don't think we have pause. Do we have pause here? Let me do. Don't forget to pause. Don't forget to pause. Cool. So that's got it right there. It's in the chat. I'll be able to find it again. But Kayla, does this make sense right here? I'm glad we found this finally. I could have just rewritten it. I just like the way I did it. But generally, we don't have a fourth condition unless... yeah, no, and we've got lots of them. So we'll be doing our own video reviews and definitely playing the Kahoot. You might win the Kahoot. Did you win? Did you already win one of the Kahoots? There's Elise right there. Caitlin, man, so crazy. It's all look random. 10% pause in the chat. Big pause. You can see them practicing along here. When do we use the expected cell count? Kayla, you got it. You just said it. The expected cell count is when we have 2 categorical variables. Well, you're doing well with this right here. The expected cell count is with 2 categorical variables. You just said it perfectly. When we're doing the chi-squared test of independence, you could, if you want, have your kids play along too. Be like, I don't know, they're probably this is click buttons or whatever. But it's just fun. I really like that people get to play along and maybe win. And I think I might even do something for the Discord. We might do something like special for the Discord, where we might do like its own like Stat Nation thing, where I might do like $5-10 Amazon gift cards, just where we only stream it on the Discord, or you can only play if you're on the Discord, just as a big thank you. And then I might do that at the start of the semester too, to try to get more people on the Discord. It's worked pretty well with the Discord this semester. Like we've got a pretty good showing, pretty good amount of people. What else are you wondering, Kayla? Let me know. We'll hop back here to the main screen. So that's really good information right there. Oh my gosh. People putting pause to that. There are the pause. Yep. Let me message Tiffany. Let me put this right here. Let's go here to Stat Tool on review page 3. And yeah, you did great on that problem. Do you want to do another problem, Kayla? Another surprise problem? Work on another problem here. Your call, Kayla. There we go. Posted that in the chat right there. Videos are all on there. Logan's got some pause in the chat right there. Jillian put some pause. Great stuff. BS train. I don't want to look at too many things lest I get confused. I'm always worried I will see the question in the stare. I think the test is more straightforward. Like I try to if you teach someone at this level and then the test is at this level, I think it's easier because you can be like, I've done harder things than that. So I try to make sure we like overcompensate. Yeah, let's do it. Let's do it. Let's practice another problem right here. Let's do it. Okay. So I want you to, we'll start off. I want you to tell me what kind of problem we're working on here. Let's hop onto the main screen and let's do this. Okay. Brian goes around campus asking students if they know statistics. He wants to find out if it is true that more than 20% of UT knows statistics. He talks to 200 students and finds out that 40 of them knows statistics. Now, if you're super fast, you can actually answer all the questions. I made this one a little bit weird, but you can actually answer all the questions really quickly if you know a lot of what's going on right here. But don't worry. Like, if you're like, you can be like, I just did the whole problem in my head, Brian, because I did this a certain way. We'll probably change the numbers as we work through this because right now the problem's a little bit not too interesting. Do you know what we're doing, Kayla, here? So what kind of test are we doing? Like, where will this problem go? It'll instruct you for things. It'll probably say, find this. Like, or what is this? Like, knowing what's in this problem and where it's going is going to be important. Like, we could write out nulls and alternatives. We could find notation right now. We could check conditions. So there's a lot of ways this problem could go, but like, I can tell you the answers to pretty much everything off the top of my head because I made it a trick. So it is a hypothesis test. So here, I'll just, that's great right there. Kale, 100 points. Don't worry, just be like, so what, do you know what kind of hypothesis test we're doing? Notations. Yeah, so give me some notation. I'm gonna let you kind of lead the way here. If you're stuck, just say, need help or something like that. And so what kind of notation do you notice in this problem right now? What notation do you see? Which will kind of lead you down the path of what we're going to do. I'll just keep asking questions. So it's like, the questions usually are more, X is 40. Yep. That's the number of successes. So that's 40. Keep going. There's not that much notation for this one. So that's X is 40. Sample size. He talked to 200 students. That's the sample size right there. Yep. Anything else you see? So you can solve for stuff now, and then there's one more thing to see. You get p hat. Yep, that is p hat. P hat is x over n, which is 40 over 200. Now, you might notice something right here. That is p hat. Now, this is where this problem's a little bit odd. What is that? You are right, p hat is 0.2. What is that 20%, though? So you are very correct. I made it weird. I wouldn't quite call it the mean. Think if you have p hat and you're doing hypothesis testing. So there's some ways you can kind of talk about that way, but we don't. It can create confusion if you mention that. Kind of, you're close. So this is what Brian is wanting to test. It's like Brian's current belief. It's where he's starting. It's like what he's hypothesizing. So it's not the truth. P would mean it's the truth. If we say that that's P, then that's the truth. Yeah. Well, you're really close with P. You're really close with P. It's just that it's not the truth. It's what Brian currently believes might be the truth. Does that make sense? It's the null. So it's not P. It's what? You're right there. You're right there. It's not P because this is what Brian hypothesizes. It's not P. It's P what? You're right there. I know you got it. I know you got it. It's not P. It's P. You got it. You got it. It's not P. It's P. Oops. It's P, which means I hypothesized. It's P naught. Naught. It's got that little hypothesized value next to it. Does that make sense? So that's what Brian's testing. So what's really interesting about this test, now are we going to find a Z or a T? So let me ask you this. When I do this test, am I going to find a Z or a T, Kayla? Will Brian be solving for a Z score or a T score when he runs this test down here? Which of these? So remember how we do when we're doing Mr. T or when we're doing Z's. Which one of these do you think we're solved for? Yep, that's the null. You got the null hypothesis. The null hypothesis is that the true proportion is equal to 20%. The alternative would be that the true proportion, Brian's looking for more than 20%. And it's not T though. Because what is Mr. T? Mr. T is what? Don't worry. Mr. T is what? T is mean. And this is what kind of data? So Brian's asking people, do you know statistics? And someone's like, yeah, I know stats. Like, cool. You count as a success. So it's Z. Yep. So this is going to be a Z-score right here. And once again, do remember this with the notation. And so I just want, if you're worried, there's no review 4. There's only review 3. If you're worried right now, category exactly. So I think, Kayla, if you're worried, like, oh man, I think if you had identified the notation, and you see we're doing a hypothesis test, and you look at the components of the hypothesis test, so you would have gotten, we're bringing up the formula sheet as we speak, formula sheet, and I think you would have been looking right here at this, and I think you would have been saying, I think you would know you're solving for a Z. Does that make sense? Like you'd say, okay, I need my P hat, I need my P naught, and then the standard deviation is P naught times Q naught over N square root, and that's going to go on the bottom. So I think, and we can identify Q naught here in a second, but I think you would have came to this hypothesis test equation right here and said, I need my sample proportion, I need my hypothesized proportion, and then I need to do the hypothesized proportion minus the complement of the hypothesized over the sample size. I think you would have gotten here. Yeah, and so then you would have said, I'm solving for a Z. Like you'd be like, okay, I'm solving for this Z-score right here because all the components show you it's a Z. Remember, Mr. T down here with the means, Mr. T is mean. So that's why we say that. Trey's a nice guy. I just don't want to disparage his name. And so right here, we're going to solve for this Z-score. The Z-score we're solving for is equal to P hat minus P naught. And the reason this problem is easy is because why? Do you see mathematically why this problem is easy here, Kayla? Like, I made a easy problem, and the p-value will also be easy. This is one we could ask you to solve the p-value without the calculator. Do you see why this will be an easy problem here in a second? Which then it's like, we don't even really need statistics. It's almost like statistics complicates the problem itself. Brian believes 20%, and then he goes out and sees 20%. So he saw exactly what he believed. Exactly. So then since 0, so you're seeing it. Since 0 is in the numerator because these two have no difference, what's the rock say about the denominator?
It doesn't matter.
The z-score is 0 because there was no difference. So when we standardize the difference, there is no difference. So do you know what the p-value is for this, Kayla? You're really on track if you can be like, okay, here, while I'm drawing it out, I want you to think about what the p-value is. You'll see it, and then you'll say, oh, that's what the p-value is going to be. But be thinking about what the p-value is going to be here. Let's see if you get it. Because once out the way we're shading and think where we landed, so the p-value is going to be what? I think you can get it. I made it kind of easier, simple problem. It is high. It is high. It is high. Do you know what the p-value is? It is very high. Like, do you know it's, so I think we landed it as z of 0. Z is equal to 0. So think what we're going to do here. What I'm going to draw, I'm going to go to 0 and shade to the right. So the p-value, when you see it, you'll be like, oh, I know what it is. So what's the p-value? Do you see it? P-value 50% or 0.50. Exactly. Great job, Kale, right there. Yep. So that one we can solve in our head. We can be like, well, it's the half of the curve. It's we shade above 50%. So it's, or above 0, which is 50% of the curve. So you might say, well, do I need to use the applet? It's like, no, we don't always need the applet. We're like, oh, you're at 0. So it's you're shading up above 0. So it's 50% of the curve. Does that make sense, Kayla? This was not that interesting to solve, but we could change it. If we change this problem now, let's say Brian instead saw 60 students. So what about this problem is going to change now if Brian saw 60 students? Like now, we actually need to solve this. I'll start writing in the numbers for this. If Brian saw 60 students, what about this problem is changing right here? Shading above. Oh, yeah, exactly. Look at the sign. Great job, Kayla, right there. Remembering, yeah, look at the sign to see which way you're shading. So Brian saw 60 students now. That's really going to impact the what? That impacts the sample proportion. Now we don't have a difference of 0. Our difference here between what we observe, 30% minus 20% expected, standardized, now we actually have to standardize it. And now we're actually going to get a z p-hat change exactly. So and the z-score is going to change because the difference changes. So now the numerator is not 0. So we actually have to solve this one now. So take a moment with me right here and solve the z-score. And then the p-value will change because now we're actually not at 0. We're actually going to be to the right somewhere at a positive z-score of some sort because we were above the hypothesized value. Great, Kayla, you got it. You're doing some great practice right here. And so now let's try to solve it. I'm going to, before I hit enter, I'll let you take a moment. Okay, because I might make an error. Oh. I can get a good guesstimate of the p-value now. That's not the z-score. I didn't think it'd be this extreme. It's going to be between 3 and 4. Yep. There we go. Great job, Kayla. You got it. That is the z-score, 3.54. Now, when you look at a curve, you only usually see up to 3 standard deviations. Here's what it looks like visually here, Kayla. Try estimating that p-value for me. Just give a decent guesstimate. And here's what it looks like visually. Let's see who can get closer. I'm going to type my answer in the chat and type your answer. It's got to be smaller than that. There's my guess. So that's the p-value right there. When we land at... Oh, wow. No joke, Kayla. I hit enter on mine. Woo! Who's going to be closer? Wow. It's like we get an over-under thing right there. Let's find out. Okay, so at this point, we probably need software to find the p-value. It's so small. David M. Lane. I know, right? Well, let's see who's right. Watch us both. Watch it be a tie or watch it be right between. Are you getting good at guessing it? It's very, very tiny. So David M. Lane's not going to give a really good estimate because it's going to be... We're both pretty close. Is it 3 zeros? Look at that. We're both within 10 thousandths of this. There might be additional decimals we can't see, so we need a tiebreaker right here. And Kayla, you might have won. So here's the tiebreaker for it. To really know the answer, we have to go here to a better applet and do p-norm. And that's the right there, and do 1 minus. And there's the answer. Kayla, I'm throwing you another 1,000 points. I know you're writing all those points today, but Kayla, you were right. Kayla, you just guessed that z-score within literal 10 hundredths, thousandths, 10 thousandths. You were less than a 10 thousandths off on a z-score. You're like, well, something about this, and you're like, yeah. If we just annotated and said 0.00002, we would have both been a lot more correct, and we would have been within hundreds of thousandths of the right answer. And we just took a guess. Like, oh, it's really tiny. It gets really hard as it gets further away. Like if you go to something like 5, it's going to be a lot. At that point, you can just say, well, it's basically this. After about 5 or 6, and I'm doing it here mathematically. Don't worry about the mathematics. These are the z-scores. Yep. No, Kayla, great job. What would you say for z-scores that are more than like 5 standard deviations? Does it go negative? Z-scores can't go, p-values can't go negative. Remember, nope, never negative because it'll always be a probability. So the probability will just get smaller and smaller. And after about 5, what would you say for any p-value? Because p-values are probabilities. So p-values range between 0 and 1. Great questions right there. After about 5, you could just say your p-value is basically this. After 5, you can be like, basically this. Be like, basically this. Yeah, no, don't, Kayla, 100 points. Don't worry. Ask those questions. It's basically 0. Exactly. You know what's really cool is what we could do. Okay, so that's the upper tail. So if we do this value times 2, that's that. And, yep. And this, guess what we get right here? I have just recreated, wait for it, 68, 95, 99.7. These are the actual percentages found via software, getting a more fine calculation, the 95.449, the 99.73. But when we do 68, 95, 99.7, these are like more decimal carried out. I can even show it even better here. Options digits equals 20. It's just that there's so many digits to these. Like, no one's going to take the time to say, this is why I love coding. Don't worry, you're not meant to know how to do all this, but no one's got the time or patience to give all these decimals. That's why we round it to 68, 95, and 99.7. But this is like, with software, you can get very exact calculations. And back in the day, people would be like, wait, you can just calculate these things like that? Yeah. I don't know. I love code. And then you can control right here the amount of digits you see and everything. Of course, you could go over here and control it too and just go to your round. So if we put a round in front of this, this is going to become the first argument. And then the second argument is how many digits do we want to round it? And now it's rounded to 3 digits. Oh, we want to turn the SciPen back down. SciPen to 7. That controls the scientific notation and the digits. I'm just getting confused. There we go. And there's it rounded to 3 digits. So I don't know. This, don't worry, I think I might even scare some 320 students if they saw this. What are your thoughts, Kayla? But this is how I'm calculating p-values here very exactly. And the reason I would do this, if I'm really getting very serious, is because David M. Lane doesn't allow us to do very exact calculations. Like, we only see so many decimals. You aren't just going to have a calculator. Yeah, I know, right? No, like, Kayla, you're on the same. Like, when I first started doing, like, no joke, when I first started doing this applet stuff, they were like, well, you won't have the applet with you at all times. I'm like, it's on my phone. Here's the normal curve on my phone. I have it on my phone. I'm probably not going to have that book with me at all times that has the table in it. I do have my phone on with me at all times. That's the normal curve. And then also I know the empirical rule in my head if I want to solve something, but I have the applet with me at all times. And I could probably like put R code on my phone or something and like code it myself to like get exact answers. Oh yeah, well here, let's talk about 320 for a second here. So we did a little bit of advanced coding right there. Like, truthfully, what I did right there might even scare a little bit at 320. Okay, so Kayla, I'm going to teach you how to make a basic regression right here. I'm going to teach you a little bit. We're going to talk about a basic regression, okay? That's pretty nerdy just saying. Yeah, I know, right? I am nerdy. I take it as a compliment. So here we go. Let's take a look. I'm going to teach you a tiny bit. We'll just do like 10 minutes or so on this. So let's set that 10-minute timer. If you got a moment, let's do it. Let's check it out. Happy Tuesday. Colin right there, 100 points from Disney. We need to talk. If it's not this semester, Colin, that you swing by for business analytics, we need to make it happen. So Kayla, I'm going to teach you how to write regression right here, which Colin knows how to do. We're going to use a data set called the MT cars data set. So we got a bunch of cars here, and I know literally nothing about cars. But does it make sense? Let me ask you what this looks like. Let's call it cars. That's going to make our lives easier. What does this look like to you here, Kayla? Just tell me if it looks like any program you've ever seen it. Does this look like anything you've ever seen before? Any sort of programs you've worked with? You know, like any sort of this? What's this look like to you right here? Just be like, oh, that looks like a this. It's like Jump. Looks like Excel. Looks like a spreadsheet, right? So we see right here the miles per gallon for the Mazda RX-4. The cylinders, it's got 6 cylinders. So here's the Mazda RX-4, and here's all the information we have on it. Now, this is the name of the data set. Just think of it as like the jump sheet. Like when you go to the jump sheet right here, this has a name. I don't know where it went. So the sheet has a name, whatever the name of it is. And then these are the what's inside of here. Think of a V word. These are the what's inside of this data frame. It's like information we collected on. You would call these the different, like, they have different types to them. Like they're all quantitative. That means quantitative right here. And you can see they're all quantitative. So these are the different what's inside of here. These are the names of the different what's inside. Variables, you got it. They're the variables. So we collected information on the miles per gallon, the cylinders, and these are the names of the variables. So let's start out here very easy. Very, very easy. So if you notice, cars is the name of the data set. And once I type 3 letters, we get what's called autocomplete. Notice how there's even a little symbol right here telling you that cars, we're not going to click on the other stuff. I don't even know what most of this stuff is. Like, not joking. Like, not like, I don't know what those are. I don't think I know any of those other than what cars is. Those are just other things I could autocomplete to. Those are libraries right there. I'm going to click on cars, and then I'm going to hit Control Enter to run it, and it runs down there on the bottom. A lot of output. But let's say I only wanted to look at the miles per gallon. Kayla, looking at the code over here and how it looks, what do you think I would put after cars to reach inside the data frame and get that variable, which will be a vector? Like a vector is just a line of information, one-dimensional. Close. That's how we do functions. That's how we do functions. Look here at this and see if you see something that would connect a data frame to a variable name inside of it. So how could we reach inside it there? And so you're on the right track. Don't worry. So how could we look here for hints? And what would we connect to do to get a variable outside of it? You got it. And watch what happens when we type this. Autocomplete comes on. Autocomplete is amazing. You see how now we can see all the names of the different variables, and we could look at the miles per gallon of the cars. So all we do, and then you don't have to do the colon right there. That's kind of like separating, like saying like, here's the weight variable and here's the like information. So all I'm going to do is just hit enter. So you hit the autocomplete enter and it just autocompletes for you. So then I'm going to run this code, and guess what we're looking at? Just explain to me, Brian, this is the what for all these things right here. And we're going to make our lives really easy in a moment. Brian, this is the what for all of these things right here. Miles per gallon for every car, right? That's like you can see the first car had a mile per gallon of 21, second car had a mile per gallon of 21. And now, can you explain to me what I'm doing right here, Kayla? Like, remember, this stored empty car as the data frame into this. This is a vector, and now I'm assigning what? Like, can you explain to me what line 2 does? Like, this is just a vector. This is, if I run this code, it's just that information. Like, I'll show you. It's just that information. And then what does this code do right here? Like, it takes and it's like arrowing it into this. What is that going to do? I can run it here and let you see what it does. Watch up here. Oh. Yes, that's exactly it. It stored it into the value X. So now we have that vector of information stored as X. Does that make sense? So now that has become X. We have created X. So now that has been created. And we're doing this to make life really easy. So you remember how to do functions. What if I want to look at the mean of X? So I think you can do this, Kayla. Imagine you have this in front of you right here, and I want you to take the mean of X. Exactly, shortened. Yeah, exactly. So you can just use this now to be like, oh, here's my X. I'm going to just manipulate it now. Close. So don't put the parentheses around the mean. Mean is the function, and then it uses X to evaluate. Super close. Mean is the name of the function, and then it evaluates X. So mean is the function, and then it evaluates X. You can get it. I know you can get it. Mean is the function, and then it evaluates X. So it'll say like, we're going to use the function mean. That's it. You got it. There you go. We took the mean of the X right there. Can you think of any other functions we could do? I know, right? We got all the Kaylas here. Kayla, thank you so much. Kayla is taking 320 next semester, so we're reviewing. I also went over Feather at the start of this. So check it out, Kayla Beard. Check out Feather at the start of this. It stores Feather files, and we were checking that out. So I took a moment. Pretty good package. Very, very easy, and it's meant to go between Python and other one. We're also looking at some R stuff right there. You have another problem? Put it in the chat. We got enough time here. And so, can you think of another function you'd want to run on a quantitative vector? Or like a graphic you'd like to make? Can you think of any graphic you'd like to make right here? Think of a graphic like, hey, Brian, could you make a this for that? Or, hey, Brian, could you tell me the this of that X vector? Because this is just a quantitative. We asked, how fast does that car go? Yeah. Well, we have the mean function. We already have the mean of the quantitative vector. So could we make any graphics for it? Could we make any graphics? A histogram. Well, let's. How many letters do you think I should type, Kayla, before I stop and let the autocomplete do its thing? How many letters? And this is a good practice because even I try to do it. So you are right, histogram. That's 100% correct because it's quantitative. So how many letters should I type before the autocomplete kicks in, and then it's going to give me tips on what I want to type? So I'm going to start typing histogram. So how many letters do I need to type? 3. Do you see any code that works? Now, I don't even know what his default is. But right here, This generates function histogram computes a histogram of the given values. So what do you think? What do you think I should write? Can you write the code for me to make a histogram of this quantitative variable? Like, what do you think I should write? What do you think I should write right here? I bet you can write the code. What do you think we should write to be like, let's make a histogram? You got it. There's a histogram of the quantitative variable. Now we'll go a little more advanced right here. You ready? Awesome. We'll go check that out here next. We got, I think our 10-minute timer is running out. How much time we got? Watch it bling bling now. 2 minutes. We said we'd do 10 minutes of this, and we'll do it next. You got it, Kayla. No, actually, you know what's interesting? R reads through spaces. I think that works. Spaces.
It doesn't matter.
You got it right, Kayla. TSBox. Ooh, gotta check that out. It's for shiny, is it? Oh, gotta check that out. So space doesn't matter. R reads through it. You can just go here and be like, wee. And guess what? We can remove this and see if it works. There you go. Still works. R doesn't. R blank spaces are just blank for R. It's like, whatever. What else was I gonna do? So do you remember how to add an extra argument? An argument is like an extra set of instructions. Like we're saying, and then do this. And think of like grammar. If you want to say and you're doing maybe proper grammar, I don't know. But what code would you put? You got it. Awesome, Kayla. Both Kaylas. Kayla B, Kayla G. And so I'm going to change the color of this histogram. What 3 letters do you think I should type to change the color? What 3 letters do you think I should type to maybe... Oh, yeah, there we go. Col. Oh, col. And it actually is just col. A color to be used to fill the bars. The default null yields unfilled bars. And so now let's just say C... What is it? Oh, Connor... Mint... What was it? No, that's not one of them, is it? Connor had all these cool colors yesterday. Teal not a color? Green's a color. Connor had all these cool colors. Let's find some cool colors and we'll end on that. Color codes in R. Cool. R color code cheat sheet. Oh, here it is. Here it is. Oh my gosh. Here's all the, like, you can do hexadecimal color coding. What is this? Cyan, aquamarine. So we got aquamarine. There you go. There's aquamarine. Seafoam. Is seafoam in here? Oh, no seafoam. No. Oh man, I was hoping some seafoam was in there. Well, you can. Oh, you can brew colors. Yeah. So there's default names for colors, but you can always go to. I'll show you one last thing right here. So this is the last thing. It's kind of a neat thing that I really like. We want to go to hexadecimal. This is just like the fun part of coding. Yeah. No, Kayla did such a cool rainbow thing, and this is a hexadecimal color coder right here. So this oh my gosh, what we got? We got previews. Okay, maybe zoom in on it. And let's try to get random previews off the screen. There we go. They're making their money on those ads, aren't they? So it's makeup stuff, I think. It says make the leap. Oh, it's Adobe. It's Adobe. Thank you, Adobe, for your random preview. You can go inside of here and choose the color you want and go through here, and you've got every single combination. And do you see this number right here? And it has this right next to it. So if you want like a really nice blue, like you're like, I want this like jean blue. I want jean blue, and that's blue jean blue right there. So this is hexadecimal color coding right here. It has that little hashtag next to it. And then we go over here and we just drop the color. We throw the hashtag, and then we've got blue jean blue. And literally you've got an insane amount of, it's at the pound sign exactly. So that's not like, it's just a neat thing. It's hexadecimal color coding, which is 16 to the 6th power. Like you literally have 16 to the 6th power combinations. So you've got about 16 million combinations of colors. So it's like you have a crayon box with 16.7 million crayons. And yeah, Kayla's done so many cool things. That was her first shiny app right there. I think had the color selection wheel on it. And we've seen a lot. It's really cool. So this is just kind of the basics right here. We talked over arguments. We talked over vectors. You can also see right here that X is numeric. I think it's actually integer. It's numeric, where we might have different things in different classes of objects, where you might have something like this, like str is a character, but we have factors and stuff. So we'll get into this, Kayla. If this is making sense, we go through at this kind of pace to start, and we talk about all the basics, where we understand what arguments are, and we understand just how to code and just ask questions. The number one thing with coding, and Kayla B will tell you this, is if you get stuck, one, ask questions, and two, put it up for a moment. So we're going to check out some more coding right here. Let's go check it out. Color selector and signing, but the rainbow was for the bars on a histogram. Yeah, do you want to, can you send me that? I could go find it. If you want me to show it, I'll show it off right here. No, it's really, Kayla, you've made so many good codes. In one of my first 320, was it 320? Awesome. Okay, wait, here it is. Current project, TSBox. Do I want to go to this link? Of course I do. Of course I do. Okay. Class agnostic time series. What? Christopher Sachs right here making class agnostic time series. The R economist known as vast number of the time series, instead of creating the ultimate 15th. Wait. Okay, so wait, they're trashing on it, aren't they? So that's funny. I think so. The Arcanist ecosystem is known as vast number of time series standards. Yeah, there's a vast number. Okay. Instead of creating the ultimate 5th time series class, TSBox provides a set of tools that are agnostic towards the existing standards. The tools also allow you to handle time series as a plain data frames, thus making it easy to deal with time series in dplyr or data table workflow. Oh, no worries. I'm reading about the TSBox right here, which is going to just handle all classes. TSBox is built around a set of converters which convert time series stored as a TS, XTS, data frame, data tibble, zoo, tisble, tibble time, and time series. I know some of these. Zoo is one that don't understand that format so well. We have the tisble, which is our FPP3 stuff. I don't know a tibble time. I know a TS. That's the objects we were using FPP2. XTS, we saw some XTS with the stock stuff. So these are the different formats. These are the whats of an object. Yep. We just actually talked about this. It's the class of an object. So this is the class of an object right here. I created a time series vector right here. I mean, not too interesting, but this is a class of an object right here. So we might start implementing this, Kayla. So we can install the latest. Well, why not? Let's just do it. Let's just break everything. We're going to install some TSBox right here. So Kayla G, Kayla G, yep. What this will do right here is this is installing new things into R for me. So this installed this package, which has like things that R can do for me now. So I basically downloaded video games. That's the way I usually talk about it, because I talk about everything like video games. So now we have this package. So class agnostic time series, which means Rock knows it doesn't matter. It doesn't matter what we're using. It's going to understand everything, because they're like, rather than create a new time series format, we're making it so these all work. We don't need the developer version. Convert everything to everything. So new toys, exactly. So Kayla B, Kayla B, can you just take your, so this is the conversion function right here. So TS underscore C, wait, TSBox can convert time series stored as TS to each other. Okay. TS tibble time. So it's currently, no, I think you made it for 475. Oh, didn't you? Oh, remember there was one class where we made a rainbow histogram by accident. It's that, yeah, I think it was in 475 we made a rainbow histogram by accident. It was pretty cool. So this is currently, well, you see they keep changing it. They're just bouncing around formats. Oh, okay, that's what they're doing. Okay. So the function is TS. It's not original format TS. They're taking The C right here looks like original concatenate. It's concatenate two vectors. So that's time series concatenate, I think. Do we have FDefs or something? Whatever that is. Wait. Oh, I lost it. Where'd it go? Do we have FDefs? Their code should work. We do. There are the deaths. And there's the mean deaths. Wait, was this forecasted? And what is MDeaths? What is that? It is monthly deaths from lung disease. So you run the question mark anytimes. Done for the day. Awesome. Have fun with the family. Enjoy. Hope you have a great time. Yeah, no worries. Let me look at those screenshots. I'll probably head off here in a moment too. Just taking a look at what the package does right here. So looks like just deaths. Yeah, no. Well, both of you will be bragged on. You might have to wonder which Kayla I'm bragging on to see which one. Okay, let me look at the screenshot right here. Okay, you've got... Oh my gosh. If my brain's trying to break it apart. Kayla, can I show these screenshots? Might make more sense if I show them. Kayla B, if I can show this. But if you're like, no, keep it over Discord, I will. So you've got a bunch of if-else. If the best forecast is equal to the naive ledger net change. Okay, then that's the variable. Okay, yeah, I probably can't run it. Or, I won't show it here. It's okay to show? I might just keep it over here. This looks accurate. You're storing the whole output. And I see you got your confidence intervals at the end with the helo. It's high-low. Oh my god, I call it helo. That's why it's called oh my gosh. Sometimes you just call it helo. It's high-low. It's highs and lows for confidence rolls. Awesome. So is the code not working? Anyway, here's the output. You're doing it on that key, it looks like. Okay, so it's making the same model for everything, right? It looks like the same model is being reproduced. Like your whole table is the same model. It's producing a whole table of models, right? Yeah. Oof. Yeah, I noticed that. I noticed that the table is... So it might be the way model... Oh, but the model only has one argument. So the way some of these run is it might not... And I've seen this... The model only... And I think this is the issue, Kayla. I think the model only takes formulas. And I've seen this with the Shiny. And this is... You're running the issues that we're running into. No office hours tomorrow. Since school's off, we do. Those are the days I don't do office hours. The only days I don't do office hours is when it's a holiday. It's a holiday. No office hours tomorrow. Thank you, Kayla. Thank you so much. I didn't see that in the Discord. I say Brian said no office hours. He's gonna be making turkey. Maybe we got to make it on Thursday. I took it out of the thing last night. It's like a 12-pound turkey. Should be making it on Thursday. Learning how to make turkey. I think this is the issue, Kayla. Do you remember that code we were running? I think we built some code, the paste output in Shiny. Let me go look at the paste output in Shiny. Okay. Oh my God. Yeah, so... You know what I might do? Here's what I might do. You might have to make here's I know, right? Here's what I would do. I know this sounds crazy. Here's my suggestion. Make all your models. So make all your models, right? Because you have to make all the models anyway because you have to check them. Make all the models. So 1, make all the models. You've already done that. 2, store the accuracies into a table. 3, sort the table by your metric. I think you're using RMSE or AIC. Sort your table. 4, only report the first row of the table. Does that make sense? So once you sort your table, sort the table, and then only report the first row of the table. So does that make sense? 1, make all your models. 2, run your accuracies. 3, sort your accuracies based on RMSE or AIC, whatever metric. 4, only report the first row of the table. So that way, you're not really, but then you need to make it, right? Yeah, it's similar right there. And could you do ifs? Then you need to grab the name of that column right there and maybe do like a plot with an if. Like if, it's a lot of if else's, isn't it? Everything's a bunch of if else's because it's just making choices. So you need to have like your plot, you know, like if this, plot this. And then if you have a best model page or something, like if it is this, plot this. If it is this, plot this. If it is this, and it's just copy paste, just like write the one plot. If best model this, run this code to make plot, and then grab that. If best model this, you might, I don't even think you need a bunch of else's, right? Because you could just do the ifs, and then the ifs will only run it if it's true. So if might work, might be bad syntax. Oh man. Yeah, switching it, and I think that's why this person made this TSBox stuff, because there's a lot of like just issues between codes. And I'm gonna look more at this TSBox stuff because it's really interesting. I might even mention in class today. They're showing it right here. Good auto plot. Are they using the auto plot? So they're using TS plot. So they're back to TS plot right here. So it's just like, I think everyone right now is fighting for which time series thing to use. And there's just so using TSBox talks and dplyr with pipe flow workflow. There we go. So they're doing, and they're piping through a TSBox, TS plot. I'll take a look at this. This is pretty interesting. So I went down the rabbit hole of DTA. Is it a data? What? Where's DTA? Oh, it's New York City flights or something. I don't think I have the New York City's Flight 13 data set. Oh, Patrick said, oh, cool. We'll have to take a look at that. Yeah. I'll take a look at that. Right. DTA. So it's got to be there. What? Where's your data set? Oh, it's taken from the weather. Yeah. I'll have to take a look probably this weekend or so. There. What? What are they doing with this code? Yeah. Okay, that. If they claim this code works. Try it again. The code doesn't work. The weather data set. There's the weather. Origin. Do they want us to select the origin? Select these columns. Columns left of time. I have no idea. I don't know. Well, we're going to get ready for class right here. I don't know. I'll be taking a look at this more, but they posted the code. What's going on? Well, with that, we will be back just a little bit, teaching some time series. Back later. Awesome stuff to check out right here and seeing what's going on with all these new packages. Love it. Bye for now, everyone. Bye.